Now, in the casino business, this is thought of as the hot hand fallacy. Someone who has had an unimaginably lucky string of rolls or a streak of luck will continue to be lucky. People bet on them, continuing to be lucky. But in reality, the next roll of the dice could just as easily bust them as it could bust anyone else in the casino. And for those of us who understand the anthropic principle, it seems that humanity is being very cavalier with the climate and the environment that we've inherited through this potentially extremely rare and extremely lucky series of coincidences. The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective addressing important societal issues. Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. On this episode, UFOs and Aliens. This kind of follows on from my conspiracy podcast a couple weeks ago. You've probably heard about UFOs and their association with alien visitors in the popular culture. You've probably heard that the military is hiding alien corpses in secret Area 51. In this episode, I discuss the possibility that aliens exist and are in fact visiting us surreptitiously and secretly for unknown purposes. If you enjoyed this podcast, please like, comment, and share it with your friends. So, UFOs. Yes, there are UFOs. Now, you may be surprised to hear me, a scientist, coming forward saying, yes, there are UFOs, but UFOs just mean unidentified flying objects, and every day there are things that you can't identify in the sky. Maybe it's a bird, maybe it's a plane, maybe it's Superman. Military papers have been declassified. You can tell that the military has been working on this because obviously it's important to them to know what's flying over your country, whether they have to shoot it down or welcome it as our new overlords. And sometimes you just can't identify that dot on a screen. And that's what an unidentified flying object is. It doesn't mean, however, that it's an alien. There really is no good evidence that aliens are visiting us. Nobody has ever brought back a bona fide alien artifact from an alien abduction. There are so many cameras out there on everybody's personal phone with really good resolution, yet all of the photos that purport to be aliens and UFOs are blurry. Why is that? Does the aliens have some sort of special cloaking technology? And why don't astronomers ever report UFOs? Because these people are looking up at the night sky all the time. They've got telescopes, they're out at night, they're looking up, they're looking at meteors, they're looking at stars, they have all the cool equipment, all the cameras. Why is it people that don't know what they're looking at that report UFOs? It's because these things aren't aliens, and if you do know what you're looking at, then you know what you're seeing. People who report UFOs typically don't have a very good understanding of astronomy or optics, and reflections in their camera, weird lighting impacts, meteors, the planet Venus often being reported as a UFO just because it's bright and it hangs low in the sky. Meteors and space junk falling to Earth are commonly misidentified by incredulous observers. And if you ever see a Chinese lantern at a festival, those things are very difficult to identify from far away. I've seen those once across a lake, and it's like, what the heck is that? It's a lantern in a paper balloon that goes up and floats in the air. Very difficult to identify. Weather balloons, also very unique things to look at when you see them high up in the sky. Difficult to identify. So what are some of the claims of alien conspiracy believers? Going back to my conspiracy episode a couple episodes ago, people have these beliefs in conspiracies. It helps them to understand things that are seemingly difficult to understand. And a lot of people will say, aliens must have built the pyramids because I can't understand how people could have engineered such a thing without heavy cranes and heavy modern equipment. And a lot of these aliens must have done something in the past are mainly based on the idea that humans aren't smart enough to do things. And this typically comes from humans who can't imagine these things. Probably not from engineers who actually are able to figure this out, and probably not from Egyptologists who actually look at the paintings on the walls of the tombs that show how they built the pyramids. We have plenty of evidence of how the pyramids were built, and it wasn't rocket science, and it wasn't aliens. Now, other claims, The Face on Mars, from a book by Hoagland. NASA low-resolution footage of the surface of Mars shows what looks to be a face looking up into the sky on a rock on the surface of Mars. Huge rock formation. Of course, we as humans are hardwired to see faces in everything. We recognize faces. It's very important to our survival to be able to recognize faces of other people. And I often see faces in tiles and in nature and abstract patterns that aren't really faces. But even because of this, because there was a big hubbub about it, NASA actually went back and re-imaged the rock in different lighting in high resolution and found that in normal lighting it doesn't look like a face. So this is not an alien monument on Mars. And what about crop circles? Here's one that this couldn't have been done by hoaxers. Well, it has been done by hoaxers. People have shown how they do it. They take boards out into a field at night. They knock down some crops and it shows up in the paper. Lots of fun. Now, what about alien abduction stories? Now, these are hard to refute. If people say that they've been abducted by aliens, but these people never have photographs. They never have artifacts. Just pocket something the next time you get into a ship and bring it back and show it to us. These abduction stories typically come out years later, after the fact. People are looking back on, why I have this psychological trauma. And during their psychological treatment for other issues, it comes out that, aliens have abducted me in the past. I'm missing this time in my mind. Well, the most likely explanation for this is false memories. There have been a lot of studies that show that false memories can be implanted, and people can believe these memories as though they happened to them, even though they didn't. And especially when it's far back in the past, it's very easy for people to get confused. Researchers have shown that people are very suggestible and can invent, things that completely didn't happen to explain their feelings. And of course, there's always the explanation of a hoax. Many people aren't beyond staging a hoax for 15 minutes of television airtime. Now, once I actually saw a video on a UFO sighting where an expert was analyzing grainy footage of a blurry dot moving around on a screen. Someone was, obviously on high zoom, so it was bouncing around a lot. And the expert stated, the acceleration from this frame to the next is so fast that craft broke the laws of physics. Therefore, it was aliens. So there's so much wrong with this statement that it deserves to be broken down. If you're on high resolution and you're vibrating your camera, it's going to look like things are accelerating, but it's actually you just vibrating your camera. And you've all probably seen this looking through binoculars at faraway objects or looking on high zoom on your cameras. And then you've got this false dichotomy of because it's breaking the laws of physics, it must be aliens. But why do aliens get special dispensation to abrogate the laws of physics? The real conclusion should be that the analysis was just crap. But no, these people thought it must be aliens. So this is my position. I don't think there's aliens visiting us. I don't think there's evidence that aliens have visited us, although I wish it was true. But just because there's no evidence doesn't mean something isn't true. It doesn't mean aliens don't exist. It doesn't mean they haven't been here in the past. It just means that you're entering the realm of speculation when you start to discuss it, and it should be treated with extreme skepticism. Always remember that extreme claims require extreme evidence. And the skepticism should be the first response to any amazing claim without extreme data. Now, we know that various defense agencies around the world have experimented with advanced stealth aircraft, and these programs are shrouded in secrecy. And it seems more likely that some of the more solid so-called UFO observations are associated with this type of close encounter of the military kind. The existence of aliens, however, is not ludicrous at all. In fact, in a boundless universe like the one we seem to live in, it is all but guaranteed that intelligent aliens exist somewhere other than just here on Earth. The idea that they have discovered our civilization here on Earth and have traveled light years through interstellar space only to engage in a campaign of secret abduction seems like a stretch. The resources necessary to mount a successful interstellar trip are currently out of the reach of our civilization. Sure, we could send a probe to the next star in a few thousands or tens of thousands of years, but the problem is that we would have to be in some sort of suspended animation if we wanted to send people, and that would take a lot of energy. We don't yet know how to make a closed ecosystem which recycles all of its nutrients and produces food with the sort of efficiency you'd need to last more than a few years before poisoning itself and killing all the crew members if they were alive and eating and pooping. So obviously there's more science there for us to do if we wanted to be able to do something like that. We're starting to just take the first small steps off of our planet and find out, what is the minimum ecosystem we need to support life. And that sort of research is very good for surviving here on this planet as well. Perhaps someday, after we've explored all the interesting rocks that there are to explore in our solar system, people will want to go and search out new stars and try to live in different star systems. Maybe once we've got the tools for terraforming under our belt as a civilization. Humans are pretty good at exponential expansion and colonization. However, one would hope that if we were to survive so long that we would also have the maturity to explore without exploiting the natives when we get there. And perhaps that is why aliens haven't contacted us. Perhaps they are visiting and looking at us. And hopefully you would think that an advanced enough civilization would not need our resources, but would merely be interested in learning. Perhaps we are so far beneath them in terms of technology and intellect that they have no interest at all in talking with us, and we're nothing more than a flea or a pet to them. The Fermi Paradox suggests that if the solar system is typical, i.e. The Copernican postulate of science, we assume that we're in a typical place unless we have evidence that we're not, then there should be lots of similar civilizations out there in our galaxy with more advanced technology than us. Why haven't they contacted us? Even with our current propulsion technology, it would be possible for us to traverse the entire galaxy in the span of a few million years in an exponential colonization sort of spread. And this is a small blip in the age of the universe, and it suggests that once a civilization has the technology, it will fan out and inhabit the entire galaxy. Why have we not discovered these people? Why have we not discovered their artifacts? So that's the basis of the Fermi Paradox. And what are the solutions to the Fermi Paradox? Well, many would argue that one or another circumstance that resulted in our appearance and evolution on this planet is highly unlikely. And maybe the first assumption that the solar system is typical is the wrong one. Certainly, there are several steps that seem highly unlikely based on our current understanding. Abiogenesis, which is the formation of the first living self-replicating chemical reaction from random processes. Following that, the evolution of the cell from these self-replicating chemicals, the evolution of the eukaryotic cell, which is the animal cell that we're based on, the evolution of multicellular beings, the appearance of self-awareness in humans, the a priori probabilities of many of these important transitions on the route to our appearance are very difficult to calculate because, as far as we're aware, they only happened once. So we just don't have a good enough knowledge of what the route was that life took to get here and how likely it really was. Now, for most of the history of the Earth, it was populated only with algae and single-celled bacteria, kind of like slime molds and that sort of thing. It is likely that this type of simple life is relatively common in the universe, from my perspective anyway. Some would argue that these life forms spread between planets by panspermia. In other words, an asteroid can hit a planet and blow chunks of dirt up into space, and these meteorites can eventually end up on another planet, and if the life forms are hardy enough, they can survive the trip and populate the other planet. And it's very possible that this happened within our solar system. It's maybe less likely that things could survive between star systems, but not impossible. When we're learning so much about how hardy the most extreme life forms are, and some of them, some cells have survived for millions of years in some kind of suspended animation. So it's not impossible. But what do we know about the likelihood of such a scenario from our understanding of our origins? Now, you're probably, if you're interested in this, probably familiar with the Drake equation. And this was a popularization to try to estimate the number of advanced civilizations capable of communicating with us in the galaxy. And it has a whole bunch of terms in it, each one representing one of the important steps in the evolution of people. And then you multiply them all together and you find out how many civilizations we could talk to. And, the equation has numbers for the number of stars in the galaxy, the rate of star formation, the number of planets for each star, the number of planets existing in the fraction of planets existing in the habitable zone, where they're just far enough from their star that the temperature is good enough for water to be a liquid, at least some of the time. The fraction of these planets that evolve life, the fraction of life that involves intelligence, fraction of intelligent life that develops technology, and the lifetime of a civilization. Now, there are about 250 billion stars in our galaxy. That's billion with a B. And there are roughly 250 billion galaxies in the observable universe. All these billions, I'm going to start sounding like Carl Sagan. It is inconceivable that we are alone in the universe. The problem is that the universe is vast, and the speed of light limits our range of communication in a human lifetime. I think Douglas Adams said it best in Hitchhiker's Guide to the Galaxy. Space is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. So what are the odds that we'll be able to communicate with these civilizations, or whether they would appear at all? If the odds are really remote, say 1 in a billion, that intelligent life would evolve on a planet around a star. 1 in a billion means there are 250 civilizations like ours in the galaxy, just our own galaxy. I read a book, it's called Rare Earth. It provides some interesting arguments suggesting that maybe we are spectacularly lucky to have evolved here on Earth. There's a lot of gates that one needs to pass through to get to intelligent communicating civilizations, and none of them are certain, as far as I know anyway. First of all, you need sufficient heavy elements beyond the hydrogen and helium that were common in the early universe to allow organic chemistry and provide a medium for life to live on. So earlier epochs in the age of the universe are unlikely to have sponsored intelligent life like ourselves. These heavier elements are formed in supernova explosions and in neutron star collisions, and they're spread throughout the galaxy. And these very heavy young stars, when they go supernova, they kind of sprinkle the heavy elements you need to have life and solid planets rather than gas giants. So these supernova fertilize the galaxy, as it were, to allow for the formation of rocky planets. Then once you have a rocky planet appearing around a star through the coagulation of dust and gas, the planet needs some protection from the star's radiation field so that the atmosphere isn't carried away by the solar wind. We know that the planet Mars, for example, doesn't have a magnetic field around it. Its core is probably cooled and solidified, so it doesn't have the sort of dynamo that Earth has that creates a magnetic field that protects our planet from the solar wind. And the solar wind is a stream of energetic particles that shoot out from the sun, and these go shooting out at tens or even 100 kilometers per second, and they strip the atmosphere away from Mars. Mars no longer has much of an atmosphere because it's being eroded by the solar wind without the protection of a magnetic field. Earth's magnetic field, of course, is created by our liquid core and maintained by some sort of a dynamo of liquid iron deep in the planet. The cores of Mars and Venus seem to have cooled and solidified so that they don't have anywhere near the magnetic field of Earth. So the radiation from the sun comes right down onto the surface and can break up chemicals that would otherwise potentially form complex molecules that might be precursors for life. Why does Earth have a magnetic field when Mars and Venus don't seem to have much of one? Well, the interiors of these planets cool over time from their formation, from the gravitational heat of formation when they coalesce in the early solar nebula. But they cool off over time, and the radioactive elements in the cores only last for so long before they peter out. And the Earth still has lots of radioactivity in it, creating heat. But it may also have a special thing. Earth, early in its history, was impacted by a Mars-sized planetesimal, or so we can reconstruct from the fact that we have a moon which is really large. And this thing must have sprayed material from the crust out into orbit of Earth, which then coalesced to form the moon. So this moon was formed of the lighter crustal elements, and then the core of this planetesimal fell in through the Earth and coalesced into the Earth's core and created a whole bunch of energy and thermal energy. And when this happened, it probably vaporized the surface and melted the entire crust of the planet. And then it re-solidified, of course. But Earth has all this extra energy in it because of this impact back, billions of years ago. And as the planets merged, of course, the gravitational heat contributed by the friction of this second planet's core following into our core created excess heat and probably, potentially even kicked off the dynamo that gave us a magnetic field. And this extra heat in Earth leads to volcanoes and plate tectonics, which effectively grow continents out of the ocean. It may be possible that, I know there are a lot of planets in the habitable zone with liquid water. They may just be water worlds without continents if they don't have plate tectonics and volcanoes. So Earth might otherwise have turned out to be a barren water world with no features on it. And that doesn't bode well for the evolution of life, or possibly even abiogenesis. Now, as I said, you need liquid water to act as a medium for life to evolve. As far as we know, this is our only data point. So going with our only data point, liquid water isn't that uncommon in the universe. And it's postulated that by some that the twice daily mixing of these prebiotic chemicals in seaside tidal pools over millennia may have been a factor in abiogenesis. So again, Earth's anomalously large moon, which is really difficult to form from most simulations, may hold the key to the arrival of life on our planet. It would seem that the angle of the collision of the Mars planetesimal had to be just right to spray enough material into orbit to form it. Now, once you've got all this, you need a star that doesn't frequently sterilize the planet with megaflares. Now, our sun is a yellow dwarf star, but which is relatively large, but there are a lot of smaller red dwarf stars out there, and they're much more numerous. And they could have lots of planets and lots of planets in their habitable zone, but their habitable zone is very close to the star because they're not as hot as our sun. So the region of orbits that have liquid water are closer into the star. And these red dwarf stars seem to go postal on their planets with these super mega flares that would be, a really bad day for our civilization if we were that close to the star. You need a star that's going to live long enough for intelligent life to evolve. It's taken us 4.6 billion years to get here from the formation of the solar system. And if your star is much heavier than the sun, it'll go supernova long before that. And if it's a little bit heavier, it's going to die quicker. It may not get to 4.6 billion years before the star goes to a red giant and envelops the inner planets. You need a solar neighborhood that's relatively quiescent. You don't want you want to be in a dense cluster of stars where supernova are going off every few hundred years, because a nearby supernova puts out a lot of energy, and these supernovas could actually ionize the entire atmosphere if it was within say 10 light years of the planet, and that would be a bad day when your atmosphere is totally ionized. That would be a problem if you're trying to evolve or survive. Now, other issues that seem to be rare or seem to be difficult. Modern oxygen-breathing animals with the sort of metabolisms that we're used to, the mammals, for example, would have been biochemically impossible until earlier photosynthetic life transformed Earth's atmosphere from reducing to oxygen-based. So the early atmosphere had these archaea, it was sulfur, there was carbon dioxide, there were bad things, but there wasn't any free oxygen in the atmosphere, even on Earth. And this is common amongst all planets that don't have life, as far as we know it. In fact, we believe that the presence of oxygen in an atmosphere is due to photosynthetic life. So you have green algae, which are taking in sunlight and they're turning carbon dioxide into oxygen. Now, oxygen eventually breaks down. It'll get bound up into iron, which is exposed on the surface of many of these rocky planets, and turn into rust. And this has happened with Mars. Mars has a lot of rust on its surface, so obviously there was some oxygen there and it got bound up. On the early Earth, we can find in the geological column, we find these banded iron rust deposits from the early Earth, which we believe is because algae was making oxygen and it was all settling as rust. All the oxygen was getting bound up and settling with rust into the sedimentary column and forming rocks. And once all the exposed iron was bound up into rust, then oxygen started building up in the atmosphere. And this allowed life, oxygen-breathing life, to evolve. So, let's assume you've gone through all these steps. You have life. Life is becoming intelligent. Just the right thing happens. The asteroid came and destroyed the dinosaurs so that the mammals could rise up, and they had the higher metabolism, and they got these big brains, and then the big brains allowed intelligence, and then they would need to be interested in communicating. Now, the vast majority of life on Earth seems happy to just exist. Not a lot of them are out there building radio telescopes. What makes us special? What makes humanity want to explore and listen to other civilizations and find them and talk to them? This is a good question. I think it's got something to do with the curiosity that drove us, the big brains. Now, advanced technology requires advanced social systems to prevent self-destruction. Once you're able to build really, really big weapons and change the atmosphere of your planet, as we're seeing, it's very possible that you can wipe out your civilization. And we still haven't figured out whether we're going to do it or not, or whether we're going to move on to the next stage of evolution. And it's possible that a lot of these steps are highly rare occurrences. The transition to multicellular life from single-cellular life from the fossil record in the geological column on Earth seems to have taken about 2.9 billion years. That's a heck of a long time. And it suggests that it's an unlikely event, or maybe it just took that time for the conditions to be right, and something changed in the atmosphere or in the chemistry that allowed this to happen. It's likely that most planets don't have stable environments for such a long time period. It's very possible that we've been lucky here, that a really big rock hasn't come and just destroyed everything and sterilized the surface like it did to form our moon. Or a really bad explosion in our solar neighborhood hasn't come and wiped us all out. So we've been kind of lucky. Is it possible that a string of unlikely coincidences resulted in the appearance of life on Earth? Is it possible that this string of occurrences was so mind-bogglingly unlikely that this is the only planet in the entire universe where this occurred? Yes. Yes, that is possible. We just don't know. Now, many people see the hand of God in this string of improbable occurrences. But if we realize that there are 250 billion stars in each of 250 billion galaxies, then even a colossal set of coincidences is likely to happen somewhere. A 1 in 250 billion occurrence happens once a day in the Milky Way galaxy. And when you start multiplying by 250 billion galaxies, you realize that some extremely unlikely things are going to happen somewhere. And the fact that we're here to observe them is called the anthropic principle, basically, if there's a likelihood of something happening, or even an unlikelihood of something happening, the fact that you are now here means that it did happen. And it's a bit of a tautology, but it's also something that you can think about. We're here because we could not be anywhere else. The planet looks like it's been specially made and evolved for us, and the environment and everything that we live in seems to be specially made for us. And the reason is because if it was significantly different, we wouldn't be here. Someone else would be here. Or something else. Maybe it would just be intelligent dinosaurs and not us, right? There's it's hard to understand the statistics. On this one special planet, it would seem that to those who have ended up here as the beneficiaries of all this long 4.5 billion year string of luck, as though some divine intellect had guided the planet through a series of improbable choices that resulted in a technologically savvy civilization. The emergence of the oxygen atmosphere, the transition to multicellular life, the emergence of mammals, the asteroid that took out the dinosaurs but didn't take out the mammals, the emergence of humanity, the emergence of language, the evolution of tool use, etc., etc. Many folks take this to mean that we don't need to get excited about the changes to our atmosphere and the rise of carbon dioxide and climate change. And whatever will happen is fated by our friendly deity or Gaia or whatever you believe in that put us magically here. Now, in the casino business, this is thought of as the hot hand fallacy. Someone who has had an unimaginably lucky string of rolls or a streak of luck will continue to be lucky. People bet on them, continuing to be lucky. But in reality, the next roll of the dice could just as easily bust them as it could bust anyone else in the casino. And for those of us who understand the anthropic principle, it seems that humanity is being very cavalier with the climate and the environment that we've inherited through this potentially extremely rare and extremely lucky series of coincidences. So depending on a lot of assumptions, there seems like there is probably a good likelihood of a few civilizations existing in our Milky Way galaxy. I don't really believe that we are that extremely unlikely here. I think that as science progresses, we're going to find that some of these things were very likely and some of these things are almost unstoppable once you have self-replicating life. Now, the likelihood that one of these civilizations, if they exist, has spotted us, though, seems negligible, almost zero. Unless they are everywhere in the universe. If they are not everywhere in the universe, if they're localized in a small area of the galaxy, well, we have only been sending radio signals out for about 100 years. And this means that if you're going to try to look for us using an RF telescope like we've been searching for other civilizations, this means that we're only identifiable over a range of about 100 light years in diameter throughout our galaxy. But our galaxy, the Milky Way, is about 100,000 light years across. Think of that. It's huge. It's unimaginably huge. And our RF emissions are only detectable out to a range, a small little sphere in this galaxy of about 100 light years in radius. Now, with our deepest full-sky radio surveys, we would not be able to hear our radio and TV broadcasts from similar civilizations even at the distance of the nearest star. We're just not sensitive enough to detect that level of random broadcast. The sort of surveys that we've done searching for radio emissions from other civilizations and mapping the radio emissions from bright stars in our galaxy could only detect the loudest direct broadcasts from intentionally beamed signals, and these would only be detectable out to about 1,000 light years distance, so nowhere near sampling the entire galaxy. Not even a small fraction, not even 1% of it. Humanity has only beamed one of these directed messages in all of its history, and that was in 1977 from the big Arecibo radio dish. So think about the odds of another civilization detecting our radio frequency emissions. It's nearly impossible. Other ways that we could be detected, though, is looking at our star through our atmosphere and looking at the absorption lines in the spectrum of that star from the oxygen in our atmosphere. And this tells other civilizations that there's life here. So people could have been looking at this planet for the last 3 billion years and noting that, oh yeah, there's life there. But what are the chances that they would know that intelligent life has suddenly evolved in the last few 100,000 years? There's no way they would know. And really, the only difference is the last 100 years or so where we've been emitting RF. So for 100 years out of 4.5 billion, we've been detectable as a civilization. Just think about the odds of an alien visitor to Earth appearing and encountering intelligent life. It's 100 out of 4.5 billion. So even if they were here, they didn't bump into anything intelligent. They probably marked this as a dead world or a boring bacterial world last time they came through, on their survey run, say a billion years ago. And we may blink ourselves out of existence. This 100 years of detectability may be all that we'll get if we don't come together and address the real problems of cooperating as humans on this Earth. Now, what have we detected using our radio surveys? Well, we've discovered many interesting radio frequency signals from natural sources that at first seemed like they must originate from aliens. For example, pulsars are really exotic objects. They're neutron stars, which are like the size, the collapsed cores of stars, which are basically all neutrons. So it's like a huge city-sized atomic nucleus. And the density is huge, and it weighs as much as 2 whole suns. And this city-sized stellar remnant rotates at hundreds to thousands of times a second and shoots charged particles out of its strong magnetic poles. And these charged particles are accelerated to close to the speed of light, and it turns into a big rotating radio beacon like a stellar lighthouse in space. Other ideas for why we haven't been contacted include the zoo hypothesis. Maybe the Earth is being kept as a zoo and being observed from afar. And this hypothesis was made famous in Douglas Adams' Hitchhiker's Guide to the Galaxy, where the Earth is actually a mosquito reserve. So none of the other planets in the galaxy have mosquitoes. They just put them all here on Earth so that no one else would have to deal with them. Or maybe it's the laboratory hypothesis. Maybe the Earth is a study from some other species and they're trying to figure something out. This was also in the Hitchhiker's Guide to the Galaxy, I might add, where the white mice and the dolphins were studying humanity rather than us studying them. Hitchhiker's Guide to the Galaxy, of course, is a great series and I highly recommend it. Now on Earth here, advanced communications are evolving quickly and becoming more and more difficult to detect at a distance. We're becoming more power efficient in our communications methods. We're getting higher speed modulations. It's becoming just about indistinguishable from broadband white noise if someone were to listen to our communications now as compared to, say, 50 or 100 years ago. Now we have these broadband RF frequency hopping transmissions, and soon we're going to have highly directional laser-based optical communications, which would be even more difficult to detect unless they're aimed directly at some other planet. And then what's next? What's beyond that? Maybe radio is not the best medium to search. That's what I'm saying here. Maybe, us looking for other civilizations, the reason we haven't seen them is we haven't discovered the best way to communicate yet, and the way that everyone else is using. And so in this way, and in other ways, advanced technological civilizations may be invisible to us, or so different as to be completely skipped over. Now, science fiction has given us a lot of possibilities here, and it's very interesting to speculate on what there might be out there. For example, I read a great story about self-sustaining magnetoplasma beings existing in the solar corona and reproducing. Or perhaps algae and slime molds are dominant on most planets, like they were on Earth for 2.9 billion years, and that's why we don't have alien visitors. Perhaps other life perceives time orders of magnitude differently than us and are communicating, but we're unable to follow the speed of their communications, either too slow or too fast. Maybe most life evolves in aquatic ocean worlds or icy moons under a surface of ice in a briny sea, and these intelligent beings live in these oceans and don't have access to space and don't know that there are stars and other planets out there and don't care. Dolphins are reasonably intelligent, but they haven't developed radio telescopes over the last 20 million years they've been around. Maybe miniaturized computer-based civilizations are possible. Maybe civilizations port themselves into massive computers and simulate their lives. Greg Egan had a great book about this called Diaspora. I highly recommend that as well. Great science fiction. Of course, if it's possible to have a mind in a computer, have a thinking computer, as it were, it opens up a realm of possibilities, including the likelihood that we ourselves are already inside a simulation of someone else's. Other reasons we can't detect aliens. Maybe nobody wants to communicate. Maybe no one's transmitting. We aren't transmitting. We aren't sending signals out to other civilizations, and maybe that's good, because there's a lot more frightening possibilities out there. Maybe intelligent life exists and it's deadly to any civilization that's daft enough to broadcast into space. Maybe they're on their way. Since this is my podcast, let me speculate. Assuming abiogenesis isn't some sort of crazy, impossible bottleneck, and there's panspermia or whatever that starts off your first single-celled life, I suspect that single-celled life forms exist on the majority of worlds in their habitable zone. They probably even have photosynthesis. They're probably making oxygen, and there are oxygen atmospheres that arise on a number of worlds. I suspect the vast majority of these life worlds would probably lose their atmosphere and their water after their core cools, before they have a chance to move on to the multicellular life stage like it happened here on Earth. I suspect the minuscule fraction which get to the multicellular life would be very interesting to visit. What fraction of these planets evolve intelligent, self-aware life? Based on the experience here on Earth, not very many. It took a long time to get to us, and we aren't a necessary result of evolution. We are a random occurrence that happened because an asteroid knocked out the dinosaurs and these small mammals evolved to take over. We aren't an ultimate goal. Evolution doesn't proceed towards the goal of intelligent life. It happens in random ways. So, what fraction of other planets in our solar system have intelligent communicating life? I'm saying it's probably close to zero based on the string of coincidences resulting in humans. But because you're multiplying it by 250 billion star systems, there's a possibility that they're here and there. There's a possibility that we would be able to communicate with them. But if they survive their so-called animal instincts and technology to become cooperative, to evolve to a stage where they have a cooperative society, then it's possible that they could spread across the galaxy and become plentiful. It would not surprise me if we were the first in our galaxy to reach this stage, but I'd love to learn that there are others out there who are trying to communicate with us. Let's hope for their sake that they keep their distance until we mature as a civilization. Thank you for listening to The Rational View. If you're enjoying what you're hearing, please consider visiting my Patreon page and becoming a patron of this podcast at patron.podbean.com/TheRationalView.